Hi everybody. Hope you're having a good KubeCon so far. I know mine's it's a little different than usual, but still very exciting to be here and be part of this amazing conference. My name is Chris Carty. I am a customer engineer with Google Cloud Canada's public sector team. When I came up with this talk, I was Kubernetes administrator and operator, so this is based off of my experiences from that position. So today we'll be talking about managing multi-cluster, multi-tenant Kubernetes with GitOps. I know it's a bit of a mouthful, but it's kind of more or less what we're doing. I can think of a shorter name. So by multi-cluster, you probably know what I'm talking about there, but multi-tenant, it's the problem that I was looking at solving when at the time was we had multiple clusters, and of course we had multiple teams that would need to be deploying to those clusters. So this is how we kind of came up with a pattern to address that issue and some of the fun things that we came up with along the way. So this is the first time I've done a live, or sorry, not a live presentation or a recorded presentation, which is quite fun. So unfortunately don't have all you fine people to present to, so instead we have our friends Optimus Prime and a couple other Autobots and a few Decepticons mixed in there will be my audience today. Not quite the same, but I expect some encouraging words and claps from Optimus Prime over there on the left. So now with so we'll get into it. So as I said, so this is based off of my experience managing multiple clusters and a large number of teams. So when we first started out, the problem that where I was looking to solve was, how do I manage, let the teams maintain their autonomy without causing this kind of situation. Every team had theoretically their own CI version or CI/CD pattern. They had their source control in its own specific location. So while we were all on Git, things could be, GitLab, GitHub, Bitbucket, a few different places. So we couldn't, as a Kubernetes administrator, I couldn't, get them to centralize on one. That would be probably a bit too big of an ask for me, and we wanted to be able to let them do what they want while getting things into the cluster with as little friction as possible, and of course without causing more fires, more pain for the developer. We wanted to do, more or less, automate all the things and have things move smoothly. So one of the awesome parts about Kubernetes is that everything is declarative. So we were able to look at leveraging tools that could use that to our advantage. So we had to initially start looking at more traditional CD aspects, so pushing the changes to the cluster. So with GitLab and Jenkins, it worked really nice, but at some point it didn't quite scale. We had to load up those CDs the CD tools with the configuration files for specific clusters, and if any of those clusters went down, came up, or were replaced, we'd have to update all the individual CD tools, which is a bit of a headache, especially when we knew that we'd have multiple zones. You'd have different dev QA prod clusters. It could be multiple of them. There could be on-prem, could be in the cloud, could be anywhere. We wanted to not have that burden of managing and maintaining where the cluster was on the development team. We just wanted them to focus on, this is my config, deploy it, right? And so that's where we've kind of focused on looking through tools, and eventually we found GitOps. So, as Kelsey here says, GitOps is the best thing since configuration as code. And probably the key point here for me is, similar to Kelsey, is this is key to dealing with infrastructure at scale. And we found this was super beneficial for that, because the development team for us didn't need to know where those clusters were. It was that burden was put on the ops team, or our Kubernetes admin team. And so we were able to work with this. So GitOps is a workflow which emphasizes Git as your single source of truth. I'm assuming most people at this point are storing things in some kind of source control, primarily Git, and so this isn't a big leap to do, which is really nice. So the workflow is, there's an operator of some kind that sits in your cluster, and its job is to monitor your Git repo and just apply the changes that it sees there. So you have a single source of truth, and then an agent which tries to make that so similar to how Kubernetes works when you give it the manifest. Right, just like, this is the state of the world, I'm going to make sure that this happens. So now we have Kubernetes trying to do that with the manifest that the agent deploys, and then the agent is telling Kubernetes constantly, this is the state of the world that I see in Git. So you have this another for loop, essentially. And one of the other benefits to this process is the developer doesn't necessarily need to have direct access to a cluster. Now, there's going to be instances where you're going to need to do this if something goes down or you have to do some debugging on the fly, but predominantly the changes will come from a merge request or PR, and the changes will get merged in and then deployed via Git once those have been approved and passes your CI. So you reduce the reliance on having people imperatively deploying things to a cluster. Instead, everything goes through Git, and then you have the kind of the baked-in benefits of Git, where it's the changes are traceable, auditable. You'll hopefully have good practice around that, so you have your PR and any discussion that comes over changes, so you can understand what's happening within your cluster system. Now, the CNCF has also started adopting GitOps. So we have two primary projects within the GitOps field. So FluxCD as well as ArgoCD. Flux is the tool that I settled on when I was building out our internal platform. Argo was a very close second. It was a really cool tool. Just it did a few extra things that we didn't need it to do, but it was still great. Flux was a little bit more lightweight, flexible, and it was just focused on doing the deployment aspect, which is what we sorely needed, as we had other things that filled in the Argo part. Do check out both of the tools, as they're both really great. They solve different use cases, but both fantastic. So this is what the Flux system looks like. So you have your Flux agent, which does the syncing, and then it also has the added benefit of being able to monitor a container registry and pull in any new tags that have been pushed to that image. So you can have this nice little automated loop. So your CD for your application creates a new container, pushes it up to the registry. Flux will see that, and it will patch the manifest, commit those changes back to Git. So that's how it achieves the constant loop there. So it's writing back to your source of truth, and then it keeps the metadata from those containers within a small memcached container. So it's pretty tight, which is nice, and that was one of the features that we wanted to leverage, just, especially within Dev QA, just so we have that quick release cycle, which is nice. So the other part, we found the tool. We did some dry runs to figure out how it worked in different processes, but we started, what was the appropriate way to structure a project? What was the logical way to put buckets to put the code in? How do we divvy that up? So digging around, looking at the best practices and it became quite clear that the best way to start structuring the application code was to keep the application code separate from the manifest. So up to this point, we had been kind of bundling everything in a single repo. But you update a manifest, and then you start triggering a Docker build. So it's kind of added time to the release process, or you start getting more artifacts and containers than you actually needed. So by separating the two, you had a more clear CI pipeline for both processes, where the app developer side is focused on creating an artifact, and so in most cases a container, whereas the app operator side was focused more on just the YAML and making sure it's compliant with your corporate standards and any policies you might have, as well as API compliant with the Kubernetes version that you'll be deploying against. So the intent of both the CIs and those repos are different, so it's nicer if they're kept separate. Sure, for smaller projects and teams, it's not a big deal having them together, but once you start getting bigger, it's nicer to keep them in their own buckets. And this is what that app operator repo would look like in a very simple scenario. Just have a folder with your YAML in it. And all the agent's going to do so there's nothing fancy happening here. It's just a deployment file. I'm missing some important things like root access, elevated privileges, but just do this just to give you an overview of what's going on. So practice, going back to the original slide there. So I, as a developer, would open up a PR against the Git repo. If things pass CI, it will get merged in, and then our Git operator, in this case Flux, will be monitoring at a specific branch or tag for those changes. And once it saw those, default is a 5-minute loop. It'll just start deploying things. And then there you have it. So I, as a developer, wouldn't need to touch the cluster at all, which is really nice. And we're able to leverage this for onboarding. So cluster access was more a heightened status. Only certain people to have access to those resources. So for developer, they wouldn't need to get access. They would have to go through an extra process to get access to the cluster, and this allowed them to keep their workflow going without having to get those elevated privileges, and to be able to box them in to keep it nice and secure, at least restrict what they do. And so part of this process, and I touched on it lightly, is the CI and how you're trying to make sure that things are compliant and ready to go. So there's a few tools that we have out there's a lot of tools out in the ecosystem, but the ones I want to focus on, and I've used, our open policy agent. So this lets, for those of you who don't know, this lets you write policy as code. Conftest is a separate project which actually just came under the open policy agent umbrella. So congrats to the team for that. That's a huge win. It allows you to run those policies within either your local machine or through a CI process. So you can start shifting left and catching those violations sooner in the process instead of having to wait for it to hit the cluster to get your pass fails. Kubeval is again from the same team that from the conftest originator, Gareth Rushgrove. So it allows you to validate whether or not your YAML is compliant or API compliant. And then kind, so that's, for those who don't know, that stands for Kubernetes and Docker. So it's a tool that lets you spin up Kubernetes in Docker containers. So this is a really nice way of getting a disposable Kubernetes cluster in your CI. You can deploy against that and test things so you get a better understanding of how your application is going to behave before it even hits your cluster. And so a example, this is very bare bones, pipeline would look something like this. You do a validation, run Kubeval, conftest to make sure things are all good and dandy, and then you test things in a Kubernetes cluster. So depending on your budget, you can either do provision something on the fly in a cloud provider, or you could just spin up kind really quick, just lower cost, and test against that. And then finally would be your release pipeline, release stage, and that would just consist of a manual approval on a PR. XYZ person has signed off on it. So say it's production, security, networking, and whoever's in charge of the change approval process, if your company has one. So the next hurdle that we started looking at or started hitting was once we had that, once we had the kind of the folder structure and the CI kind of decided and how that was going to work was, well, how do we kind of manage all the different teams? So this is where we kind of bumped into our multi-tenant issue. So do we have everyone putting things against a single Git repo and just have that define the cluster or clusters? So different through either different folders or different branches, or do we continue letting the teams have more autonomy, right? So each team would have their own specific Git repo that they'd be storing those against, and find some way to reconcile against those. So those are kind of the general patterns I've seen. I think Argo does something different, something around those lines too. The Flux team came up with their own pattern, which I quite enjoy, and I'll show you that in just a few slides. So I just want to talk about the single repo for a minute. So the single repository, like I alluded to, there is just a single repository with a bunch of folders. You can organize that however you want, depending on your team structure or however your projects are organized. In this case, I have a folder for cluster admins, and then we have some monitoring, networking, security folders under there. So presumably we would have something like Elastic Stack, network policies, maybe something like Falco, OPA with Gatekeeper, all organized up there. And then each team would have however they want to set things up. So it would be, in this case, I have a folder for app under each team. And then all the Flux agent would do is sync against that and just recursively deploy all the YAML. Right, so depending on how large your team is, this could get quite big at some point, given that Flux is just doing a git clone. So all it takes would be for one team to misconfigure something, and then your deployment might fail or something like that. So smaller teams, I see this working really well, but once you start getting into larger enterprise situations where you have quite a few teams, it starts getting a little clunky. This is what it would look like from a multi-cluster point of view. So we have all of our teams, they deploy against the single Git repo, and then we have an agent in each cluster or clusters with an agent pointing to the right branch. So in this case, we have just a 3 cluster setup. So each branch is each cluster is syncing with say dev, QA, prod. Pretty straightforward. And there are different ways you can do this. If you have different folders, you can just customize to pull off of base, and you can break things up like that, which is nice. And then you can start doing kind of organizing clusters by kind. So, for example, you want to have everything, say security has a group of policies, you want to have everything going to like a heightened security area, and you can start doing neat things like that, which I find a lot easier to achieve in the multi-tenant repo, the MultiRepo structure, but there's ways you can do it within this model as well. You've got a hybrid approach. So the MultiRepo structure is where you have every team has their own repository. And it would look something like this. And this is adapted from the Flux team's multi-tenant pattern. So we'd have a single agent which is in charge of cluster-wide resources, as well as managing the Flux agents which would sync with the team repositories. So that cluster-wide admin agent, you'd be creating your namespaces, RBAC policies, quotas, role bindings, or cluster role bindings, those kinds of things. And then each team, they would define within that cluster repo their namespace, or could open a PR, or you could create it. So they'd just be doing those things. And there'd be an agent which gets provisioned in that namespace, which would sync with their own repo, and that would be namespace and scope. So you give them a lot more freedom to do what they want, but you have, from that one cluster repo, a lot of control over what they can do. And then you also open up a lot more visibility. So depending on how you want to work, they could open up a PR if they want to change anything against their main repo, or you can open up tickets and you can change it, but they would still be able to see what's happening within their namespace, even though they couldn't change it directly. And this is, so I mentioned this briefly within the a couple slides ago, but it's nice where you can, with this, you can start using branch tag equals a group or environment of clusters. And so if the security team, say networking team, they had their own repos, they could start defining on their own, say, groups of policies, or for zones of clusters, right? So a high, medium, low zone, or PCI, or however you want to, your teams organize themselves. So the security team would just need, both those teams would just need to commit their policies to those specific branches, and then I, as a cluster admin, would just be able to, sync or tell those clusters that were going to be in those regions to sync with their policies. So as soon as they changed them, those clusters would get them right away. And if I booted up a cluster, they would get those policies again right off the bat. So those individual teams wouldn't need to update their CI processes to target the new clusters that have come online. So the fun part is the clusters become a little bit more ephemeral to the teams, or abstracted away. So they know they're there, but they don't need to know where they are exactly or what they are. It's just that the policies are getting targeted and deployed effectively, which is really cool and quite powerful, especially if you're trying to affect change on tens or hundreds of clusters, depending on what the kind of organization size you're looking at. And just to be able to do that with a single PR or commit is quite powerful. And so this is what that tenant structure would look like. So it's similar to the single tenant structure, but it doesn't have the nested folders within the team folders. So all the team folders would go under the cluster directory. And so, like I said, there's agent description for Flux. Then you have your config file, kubeconfig. This is all leveraged on customize. Under the base, there's the main Flux configuration. You have your namespace, PSP, and RBAC. And then each team is just going to get that, and it describes the agent, which then gets deployed to the environment. And then that Flux agent will look like this. You're telling it what repo it's going to, the namespace it's targeting, as well as the branch. And if you're doing this in a more open fashion, the teams again would be able to open up a PR, change this, and then bring it in, so you can give them a lot of autonomy to do what they need to do, while also having a lot of oversight in what happens. So your cluster environment becomes a lot less of a black box. Like, what's deployed where? What am I deploying to? Where are things? And now we'll get into a quick demo, just to show off what this could look like in practice, and just to show you it's not, it's pretty cool just to be able to see it work. So I'll have 3 clusters running, 2 of which will already be synced with our configuration, and I'll just bootstrap more or less that individual cluster, or that single cluster that's not synced, just to show you that how it can inherit the process, or inherit all the features of those clusters. Okay, so now for our quick demo. We're almost at the end of the session, so this won't be too long. It's going to show how to bootstrap a cluster and bring it in line with a few existing clusters in a multi-tenant scenario. So right now we have 3 clusters, dev, QA, prod. And they're all syncing up to the main repo on the same branch. Probably want to have it separated out in an actual scenario, but this is just a demonstration, so I'm cheating a little. So I'll take a look just to show you what's in this cluster. So I'm in the the prod cluster. Then we have a few different namespaces. Right now I'm in the demo app namespace, which simply has a little web app that I wrote. The Falco namespace, or Falco system, has Falco running, and then Gatekeeper has Gatekeeper running. You can see there's several nodes in the cluster. They're all doing things. So the same thing goes for the QA cluster, or sorry, the dev cluster. The QA cluster is the one we're going to bring up online. So if I do that, it's going to be in the, there we go. Same scenario as the prod cluster. So we're in the demo app namespace. Yeah, we got same app. So if I switch my namespace over to Falco just to show you what's going on there. Same setup, different context, different cluster. So I go over to my QA cluster. Yeah. So it's going to be bare bones, nothing there as of yet. So what I'm going to do is run a quick little script which just installs the Flux agent and updates the SSH key to allow it access to the cluster in which everything's stored at. So I'm just going to run that. Go. So I'm just switching over to context, and that cluster, or sorry, that repo that's syncing against is right here. So it's pulling all the resources in from this folder here, and then each one of these folders is going to generate a Flux agent, which will sync up to a specific repository. So the demo app here will point to this repo here, which has the configurations stored in the deployment repo. You can see here if I go into Flux patch, everything is set there, so it's pointing everything at the deploy folder on the main branch at that target. The Falco repo is going to look a little different because it's running using it's being deployed via Helm. So let's just take a look here. It's only read-only, and then it's being pulled from this Helm branch or repo that I have set up. So I'll just go there just to show you. Oops, I guess I could just. Sorry, I've been on a Windows or Chromebook for a while, so I have my command key flipped around. There. We'll go here. All that's sitting in here is the values file for Falco. So there's our Helm release information. And then if I go here, these are, this is what it would look like for just a standard Falco release. I'll go back to the Helm release here. So it's kind of Helm release, and then those values are right there. So you can see I have down here, RBAC is enabled, PSB should be enabled, and then I have, I think, eBPF turned on, so it works with GCP. All right, so now if I go back to the cluster, hopefully everything has booted up as expected. And there you go. So I've deployed all this infrastructure, or most of the infrastructure, without having to touch much. So if I look at the Falco system, so I'll just switch over to Falco. I'm not picking on Falco for any other reason other than I like saying it right now. So you can see that the agent is there and it's not doing, or nothing else has been deployed. That's because the agents that were deployed by the master don't have the respective SSH keys to access the clusters, or sorry, the Git repos. So in order to kind of bypass that, I just have a script that just deletes the secret that's in there and recreates it with the right key, which is stored locally, so nothing too magical happening there. So now, if I go do this, it'll take just a couple minutes just for that agent, or the 5-minute cooldown time for every sync to take effect. But if I go, let's try a different namespace. So Falco one, because it has to go through a Helm deploy, it takes a little bit longer. So let's go take a look on Gatekeeper. There we go. So it's already starting to roll out. So now we have Gatekeeper up and running in the cluster. Everything's going to be syncing from its repository. So if I, or say the security team, set up a central control for all the Gatekeeper policies, I would automatically be getting those and the configuration in which they've set up in that specific branch or policy. Same goes for Falco agents. So they should be up now. If let's take a look. Let's show the labels. Oh, because it's a daemon set. There we go. So let's do logs. All right, so there you can see everything that's putting out there. It's getting set up. So we're good to go. And that's kind of how you'd bootstrap everything and get it going. And that's bringing things in sync from different clusters into a single cluster, or sorry, across multiple clusters from multiple repos. Okay, so I hope you enjoyed that demo of showing how we bring on a cluster with existing repositories using the Flux agent and our multi-tenant repository. So hope you enjoyed the presentation overall. I know it was try to keep it high level, being that this is an introductory course or session. But I hope it gave you an idea of how you would approach building your multi-tenant solution going forward. We have our multi Git repo pattern, or even a single Git repo, and some of the pros and cons of approaching that, and how we apply those to managing multi-tenant, multi-cluster Kubernetes. And so I will be in the chat for a little while, but if you have to get to another session, or you want to reach out to me at a later date, feel free to reach out and contact me on Twitter or Kubernetes Slack. You can find me in both places at Macintosh Prime. I've also a few resources here for you to take a look at that I found quite helpful in my journey. And the one by Steve Wade from Metal is quite new, but it's a really good example of how you can do this in a practical way. Oh, and thank you for having me today and tuning in. I hope you enjoy the rest of KubeCon, and I hope that we'll be able to meet up in or see each other all in the real sometime in the near future. Until then, hope everyone stays safe, enjoys the rest of summer, and of course, again, have a great KubeCon. Thank you very much.